This video, we will take a look at the second problem that I assigned to you using Excel, which is to determine the enthalpy of vaporization of water based on the given data, temperature, and the vapor pressure. So let me now go ahead and share my screen with you. Okay, here we go. So here we have temperature, which was in degrees centigrade. Here we had the vapor pressure in torr. And this is the graph that I expect you to create. Notice that we have 1 over temperature in Kelvin on the horizontal axis and the natural log of vapor pressure on the vertical axis. We get a straight line with a negative slope. And this is what we will use in our calculations. Now, you might have a question, how do I go ahead and create this particular graph? So let me go ahead and copy all of these and open a new Excel file. So let me go ahead and paste my data. Now, let's make this a little bit larger so that you can see this. Okay. What we will do is we will go ahead and create a formula in Excel. So we want to have our temperature in Kelvin. Then we want to have the inverse of that temperature. And finally, we want the natural log of vapor pressure. So let's go ahead and label our axes. So this is what we want to create. Now, the temperature in Kelvin is the temperature in degrees centigrade plus 273.15. So I go into Excel and type equal to. I highlight this temperature in degrees centigrade and then add to that 273.15, and I get my temperature in Kelvin. Now, just in case you could not see this, let me do this again. Equals the temperature in degrees centigrade plus 273.15, and that's my temperature in Kelvin. Now, I could take each of these temperatures and add 273.15, but it's easier to copy this formula. So I highlight it, hit Control C, and so you notice that this is highlighted. Then I go ahead and paste this by hitting Control V. I need to invert these temperatures, so I type in equals 1 divided by this quantity, and this will give me my temperature in inverse temperature in degrees Kelvin. And if you see a 0, don't be alarmed. We just need to increase the cell size. Okay, let's repeat this. Equals 1 divided by this cell. And so I now get my temperature inverse. Control C to copy the formula. Control V to paste it. And finally, I need my natural log of the vapor pressure. So type in ln open parentheses, highlight the cell which has the vapor pressure, close parentheses, hit enter, copy the formula and paste it. And now you have these two columns which we are interested in now. So we will make a graph of 1 over temperature on the horizontal axis, the natural log of vapor pressure on the vertical axis. So we will go ahead, insert, scatter, and we need to go ahead and add a trend line. We know how to do that. So we'll add a linear trend line, and then go ahead and add the equation of the line and display r squared. So this is what we get. Now I have not labeled my horizontal and vertical axis, which is something that I need to do. Now you get the equation of the line minus y equals minus 5303.4x plus an intercept, and we are going to use this to do a calculation. So let's go ahead and show you how to do the calculation. So the slope is minus delta H vaporization over R. I'm interested in delta H vaporization, so I rearrange that equation, and now I go ahead and substitute the value. This is the slope with units of Kelvin, and I multiply it by the value of R, which is in terms of joules. I get a number in joules per mole, and I divide by 1,000 to get so many kilojoules per mole. And so what I want you to turn in then is a spreadsheet that looks like this, where the axes are labeled and the enthalpy of vaporization is given in terms of kilojoules per mole. And so we will go ahead now, and I will stop recording.